few things that I wanted to go over, at least that were review from the previous week. So let's just look at Schoology to start. We'll get to this in a second. This thing is always in the way. All right, there we go. So you'll see that in week 6 here, we've got a couple lessons. Again, I know when the stuff can get a little bit more tricky or complicated, I try to break it into multiple videos or break it up into multiple days. So that it's not like super overwhelming. And then you'll see that week 7's already posted. Again, we basically introduced the stuff this week. I want you to review and then take your unit 2 quiz number 2 right here. So next week is a short week. There's only school on Monday and Tuesday, then it's MEA break. So again, finish up this week if you wanted to work ahead and be done. Again, there's only 2 days of school, so we won't have a class connect next week. All right. As far as a couple things, one thing that we talked about was the complex conjugate, which deals with the standard form, all these things, basically imaginary numbers. So let's just look over here for a second. So imaginary numbers, it's a real number multiplied by the imaginary unit. And basically how it works is that anything to the power of 0. So if we take the imaginary 0 and the imaginary number, we take it to the power of 0, it's still going to equal 1. And then our imaginary number, again, what it means is that, like, and we'll talk about the fundamental theorem of algebra tells us that there are as many zeros as one less than our highest digit. But we can't always see them all the time. And again, the reason we can't is that they're a part of the imaginary number system. But we can still manipulate it and use these things. And so, again, this is our standard form, a plus bi, where a is the real numbers. We're used to dealing with real numbers. We like the real numbers. And then imaginary numbers, b is still a real number, but we multiply it by the imaginary number. However, you'll notice some things. So again, any power to the power of 0 equals 1. Any power to 1 equals itself. But when we take I squared, so when we take I times I, it's going to equal -1. And then I want you to think about, well, I times I to the third power, that's like I squared times I to the 1. So I squared is -1 times I. So that's how I get negative I here. So again, it's really like saying I times I times I, but I times I is -1. So I'm left with -1 times I. And that's kind of the same idea we can get with I to the 4th. It's really I times I times I times I, but that could be written as I squared times I squared. And I squared equals -1. So -1 times -1 is +1. So I like to think about the imaginary numbers as kind of being like a for loop system. Like depending on if we have I to the 1st, I to the 2nd, I to the 3rd, or I to the 4th, we're going to get one of these 4 numbers. And you can see it repeats. So this pattern kind of continues on forever. Let's see here. Is there conjugates right here? I think that's on the other one. So again, this is what we were talking about, real numbers, imaginary numbers. Can we make it equal to 0? First part is a complex conjugate. So a conjugate kind of means like the opposite. So whatever this number was, if a was 5 and b was 7, the conjugate would be a minus 7i. Or if a was 2 and b was 3, the conjugate of a plus 2i would be a minus 2i. So the conjugate is basically the same thing, but whatever your addition or subtraction sign was, you got to flip it. You got to change it. And so this is going to lead us into the fundamental theorem of algebra, which again deals with finding roots. So I think that's all the way up here. Okay, again, this is old stuff. This is from algebra. Again, we talked about the roots. You can have positive and negative roots, but we can also have something called imaginary roots. Knowing the roots, we can figure out the factors, which again is kind of what we're gonna come down to and want to figure out. So we've got our complex numbers. We take out and we say, all right, can we make this equal to 0? And the answer is yes, we can. So again, if we were to graph it, this might be one that's relatively easy to graph. Again, I got a 1, a -1, and a 0. Notice that this doesn't touch my x-axis, which is why I get this number of 0.866, and then the conjugate is -0.866, because we have complex roots. So we still have a root even though it's not moving through our x-axis. So how do we go about solving it? Well, again, they are still going to work. So we've got these as our factors. And then again, if we took the positive and the negative of it, that would be our zeros. Talked about complex roots always coming in pairs. Again, this is that conjugate that I talked about. So again, the roots 0.5, they rounded this to -0.866i and 0.5 plus 0.866i. And again, all you got to do is change the sign in the middle. So again, what are your options? You're never going to have an odd number, right? You're either going to have no complex roots, 2 complex roots, 4 complex roots, because they always have a conjugate. So, and again, we kind of know this. If there's a degree of 1, there's only going to be 1 root. That's like a linear line, okay? Crosses at one spot. That could be a constant. Degree of 2 is quadratic. We either have 2 real roots or 2 complex roots. So again, the example, x squared minus 9, it had 2 roots at 3 and -3. They were real. This example right here, we had 2 complex roots because again, it did not touch that x-axis. All right, again, here's that linear example, 1 real root. If we didn't want a complex number, again, what could we do? We could multiply by the conjugate, which if we think about our FOIL, a times a is a squared. This gives me positive b times negative b, and then I times I, if I remember, I times I gives me -1. So that's where we actually get some nice stuff, because this is really negative b squared I squared, but I is -1. It's going to cancel each other out. Then I get the same thing over here. Again, negative times a negative is a positive. It's going to cancel out. And then b times b gives me b squared. So if I took a look at this one, again, I could try to factor out a linear factor, and I get x to the third minus 1. I can say, all right, I'm going to take out an x minus 1, and I'm still left with x squared plus x plus 1. And I can't go any further than this without using a complex number. So again, if the question asks you to keep going, keep going. But if you can't, and we can call that an irreducible quadratic, saying, hey, we're going to ignore the complex numbers for right now. We're just going to call it irreducible and move on. So sometimes in math, we do that just again to keep things moving along. If you take, again, your quadratic, a squared plus b plus c, okay? If you take b squared minus 4ac and you get a negative number, when you solve b squared minus 4ac, and again, a stands for your first coefficient, b stands for your second coefficient, so a goes with the squared, b goes with the variable, and then c is just whatever your constant is. That's how you can determine it. So again, a is 2, b is 3, and c is 5. When we go through and solve this, we get -31, which tells us that it's irreducible and we are going to have to use the complex numbers. Another important thing to talk about is multiplicity. And again, I've seen people kind of goof this up on their quiz. When we get a root that shows up more than once, or we get a root that happens multiple times, we say it has a multiplicity. So like again, this example, if we were to factor this, we get x minus 3, x minus 3. That means that again, what would make x minus 3 equal to 0? 3. So 3 happens twice, so it has a multiplicity of 2. A polynomial of a degree n has n roots. So like we're talking about right here, the highest factor is a 4, so there should be 4 roots and 4 factors. However, when we factor this out, we get x third and then x plus 1. It's really like x times x times x times x plus 1. So there are 4 factors with x appearing 3 times, but there's only going to be 2 roots. Again, if any one of these x's is 0, the whole thing's going to equal 0. So 0, 0, 0, which means it has a multiplicity of 3. And then negative 1 plus 1 would equal 0. So this has a negative 1, and it's only a 1 time. So by counting all the multiplicities, we have 4 whole zeros, or we have 4 roots, but 3 of them are 0, and 1 of them is 1. So a polynomial of degree n has n roots where the polynomial is 0. Again, don't forget about multiplicity. Roots may need to be complex numbers. Complex roots always come in pairs. B squared minus 4ac can give us an irreducible quadratic. We can factor it into linear factors or irreducible quadratics. And sometimes a factor appears more than once. This is multiplicity. All right. I'm going to post the link in the chat, and then we can do some practice. Functions. Let's see here. Gotta find it. All right, let's just try this one out real quick. Post the link. All right, gonna share my screen, and so if you're watching the recording, you can try some of these. Remember, I squared equals -1. And remember, you cannot take the square root of a negative number unless it is imaginary. Because a negative times a negative equals a positive in the real numbers. All right, let's go ahead and wrap up. Looks like you've got a pretty good understanding of this stuff, which is awesome. That's great to see. And I hope that translates over well to your quiz. Okay. So to wrap up class, let's go to our Class Connect assignment, pre-calc, open up the folder. Looks like it's got the wrong label. Change that. What are the factors of x squared minus x plus 1? This is the problem that we did together at the beginning. We were looking over it. Again, when we found our complex numbers, we graphed it and we found that we got 0.5 minus 0.866i and 0.5 plus 0.866i. So we're going to go ahead and mark those as, let's see here. We had one positive and one. I guess either of these would be correct, technically. Let's see which one I put. This way I know you guys will be, I'll change it, but okay, we put C, x minus 0.866i and x minus 0.5 plus 0.866i. So letter C. And next question. Multiplicity occurs when a factor occurs more than once. Okay, multiplicity occurs when a factor occurs more than once. So the word occur is occurring a lot. That was my attempt at being funny. Anyways, no Class Connect next week. Finish up this week, and then you can, once you feel ready and you've done your review, take a quiz, and I'll see you in a couple weeks, okay? Bye.